Hello there, and welcome to The Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into a question that has lingered at the edges of human curiosity for centuries. How many universes are there really? But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe. Only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a joy to see all the places we gather from, each in our own little slice of time. Now, feel free to dim the lights, maybe turn on a fan for a soft background hum, and let's gently begin our journey into the multiverse together. And if your mind begins to wander, that's perfectly fine. Let it drift. We'll still be here, quietly unfolding the story. If you could step outside yourself for a moment and look at human knowledge from a distance, it might not look like a collection of facts or equations. It might look more like a small flickering light, floating in a vast and silent fog. For most of our history, that light was very dim. There was a time when the world you could walk across was the entire world that existed. Mountains marked the edges of the known. Oceans were not just bodies of water, but boundaries between reality and mystery. Beyond them lay not new lands, but uncertainty itself. And slowly, almost imperceptibly, the fog began to lift. A coastline here, a distant continent there. Each discovery didn't just add something new, it pushed the darkness back just a little further. What's fascinating is that this pattern didn't stop at the surface of the Earth. It continued upward, into the sky. At first, the night sky seemed simple, a dome of stars fixed and unchanging, perhaps placed there for decoration, or guidance, or meaning. But over time, that quiet ceiling began to deepen. Those tiny points of light were not just lights, they were distant suns, and those faint smudges between them were not clouds or illusions, but entire galaxies, each containing billions of stars of their own. The light grew brighter, and yet the fog did not disappear. It simply moved further away. Even today, with telescopes that can peer billions of years into the past, we are still surrounded by that same quiet uncertainty. It lingers not just at the edges of space, but woven into the very structure of reality itself. Because there is something subtle, almost unsettling, about the universe we observe. No matter how far we look, there is always a boundary, a gentle edge beyond which we cannot see. Not because there is nothing there, but because light itself has not had enough time to reach us. Imagine standing in a vast, dark field at night, holding a lantern. The light spreads outward in all directions, revealing the ground beneath your feet, the air around you, perhaps the faint outline of something just beyond your reach. But beyond that circle of light, the darkness remains. Not empty, just unseen. Our observable universe is a bit like that. A sphere of visibility, expanding slowly as light travels across time. Everything we have ever observed, every galaxy, every star, every distant flicker of cosmic history, exists within that glowing boundary. And beyond it, the fog thickens again. Now here's where things begin to feel a little different. A little more expansive. Because physics, our best attempt to understand the rules of reality, whispers something intriguing. Suggests that this visible region may not be all there is. In fact, it might be just a small patch of something far larger. Perhaps infinitely larger. It's a strange idea, but also a quiet one. That everything you've ever known, every story, every moment, every breath, exists within a limited region of a much grander structure, a structure that may extend endlessly in all directions, far beyond anything we could ever touch or influence. And if that's true, then the darkness beyond our cosmic lantern is not empty at all. It may be filled with more of the same, more galaxies, more stars, more planets, perhaps even more versions of familiar things arranged in unfamiliar ways. But we'll take our time getting there. For now, it's enough to simply sit with the idea that our understanding has always been shaped by what we can see, and that what we can see has always been limited. There's a quiet humility in that realization, because every time we've believed we had reached the edge of knowledge, the universe has gently shown us that there was more waiting just beyond. Not loudly, not dramatically, just patiently, like fog slowly lifting from a landscape that was always there. And so tonight, rather than rushing toward answers, we'll do something softer. We'll follow that pattern of discovery. We'll let the light expand just a little further, step by step, layer by layer. Not to chase certainty, but to become comfortable with the mystery. Somewhere within that mystery lies the idea of the multiverse, not as a single theory or a single claim, but as a collection of possibilities, different ways of understanding what might exist beyond the edge of our perception. Some of these ideas are grounded in careful observation and mathematics. Others are more speculative, like sketches drawn in the margins of our understanding. But all of them share something in common. They begin with the simple, almost childlike question, what if there's more? And as we gently explore that question, you may begin to notice something interesting. The further we move from what we can directly observe, the more reality begins to feel fluid, less like a fixed stage, more like a landscape still being revealed. And perhaps that's what makes this journey so calming. Not knowing everything, not needing to, just drifting at the edge of what is known, and letting your mind wander into what might be, because the fog is still there. It always will be. But with each new idea, each new perspective, we illuminate just a little more of what lies within it. And sometimes that soft glow is more than enough. In the quiet that follows, we'll begin to look more closely at how our understanding of the universe itself changed, and how, not so long ago, we believed it was far smaller than it truly is. A reminder perhaps that even our biggest ideas can begin as something very small, and then, slowly, they grow. There was a time, not so long ago in the grand timeline of the universe, when everything you see in the night sky was thought to be everything that existed. If you had lived a little over 100 years ago and you looked up at the stars, you would have been gazing at what many believed was the entire universe, a vast, beautiful, but ultimately contained system, a single great island of stars known as the Milky Way. It's a comforting idea in a way, a universe that has edges, a universe that can be understood as a whole, something complete, something bounded, something that fits neatly within the limits of human imagination. But as it turns out, reality is rarely so accommodating. In the early 20th century, astronomers found themselves standing at the edge of a quiet but profound disagreement. It wasn't a dramatic conflict, not the kind filled with raised voices or sudden revelations. It was something softer, a difference in interpretation, in perspective. At the centre of this discussion were two astronomers, Harlow Shapley and Heber Curtis. Shapley believed the universe was relatively small. To him, the Milky Way was not just our galaxy, it was the entire cosmos. Everything that existed was contained within it. The faint cloudy patches seen through telescopes known as spiral nebulae were thought to be small structures within this larger system, perhaps distant clusters of gas or regions where stars were forming. Curtis, however, saw things differently. He suggested that these faint spirals were not small objects within our galaxy, but entire galaxies themselves, vast collections of stars far beyond the boundaries of the Milky Way. If he was right, then the universe was not just larger than expected, it was unimaginably larger. In 1920, these two perspectives were brought together in what would later be called the Great Debate. There was no clear winner that day, no decisive moment where one idea clearly triumphed over the other. Instead, the question lingered, unresolved, like a thought that refuses to fully settle. But quietly behind the scenes, the universe was preparing to reveal its answer. On the west coast of the United States, a young astronomer named Edwin Hubble was studying one of those faint spiral clouds in the sky, a soft blur of light known as the Andromeda Nebula. At first glance, it didn't seem particularly special, just another distant smudge among many. But hidden within that faint glow were tiny flickers of light, stars whose brightness changed over time in a regular, predictable rhythm. These were known as variable stars, and they held a quiet secret. Some of these stars behaved like cosmic metronomes. Their brightness rose and fell in steady patterns, almost like a slow, repeating heartbeat. And what astronomers had discovered was that the rhythm of that heartbeat was connected to how bright the star truly was. A slower rhythm meant a brighter star, a faster rhythm meant a dimmer one. This meant that by simply watching how a star's brightness changed over time, you could estimate how much light it was actually producing. And by comparing that to how bright it appeared from Earth, you could gently infer how far away it must be. It's a bit like seeing a distant candle in the dark. If you know how bright the flame should be, and it appears very faint, then you know it must be far away. Hubble used this idea to measure the distance to those stars within Andromeda. And what he found was astonishing. They were not just far away. They were so distant that they lay far beyond the boundaries of the Milky Way. And that meant something remarkable. Andromeda was not a cloud within our galaxy. It was a galaxy itself, a vast island of stars separate from our own, drifting quietly through space. In a single realization, the universe expanded. Not gradually, not step by step, but all at once, like a curtain being pulled back to reveal a much larger stage. And if Andromeda was a galaxy, then perhaps all those other faint spirals were galaxies too, each one a distant world filled with stars, planets, and possibilities. The Milky Way, once thought to be the entire universe, was suddenly just one of many, a single island in a cosmic ocean. There's something quietly humbling about that moment, because it reminds us that even our most confident beliefs can rest on incomplete views, that what feels like certainty can sometimes be just a limited perspective, shaped by what we happen to see. And it also suggests something else. If our understanding of the universe could change so dramatically once, it might change again. Perhaps even now, there are boundaries we accept without question, edges we assume are real, simply because we cannot see beyond them. But just as the astronomers of the early 20th century could not see beyond the Milky Way, we too may be looking out into the cosmos with a kind of built-in limitation, not because the universe ends, but because our ability to observe it does. And so the idea begins to take shape, slowly and gently. What if the universe we see is not the whole picture? What if it is just one region within something much larger? A small clearing in a much wider expanse. As you sit with that thought, you might notice a familiar feeling. Not confusion, not discomfort, but a kind of quiet curiosity. The sense that there is more to discover, more to understand, even if we can't quite reach it yet. And that feeling is not new. It's the same feeling that guided those early astronomers, the same gentle pull that led them to question what they saw, to look deeper, to ask whether those faint smudges in the sky might be something more. And in asking that question, they changed our understanding of the universe forever. The fog lifted just a little, and behind it, something far larger was waiting. As we continue, we'll begin to explore the limits of what we can actually observe. Not just how far the universe extends, but how far light itself can travel, and why that creates a natural boundary around everything we can ever know. Because the universe doesn't simply hide things from us, it hides them with time. There is something quietly fascinating about the way the universe reveals itself to us. It doesn't arrive all at once, fully formed and easy to understand. Instead, it unfolds slowly, patiently, like a story told over unimaginable stretches of time. And at the heart of that story lies a simple but profound idea that seeing is not just about distance, but about time. When you look at something nearby, a book in your hands, a wall across the room, you are seeing it almost instantly. Light reflects off it and reaches your eyes so quickly that it feels immediate, effortless. But when you look at the night sky, something very different is happening. That light has been travelling, not for seconds or minutes, but for years, sometimes for thousands of years, and in the case of the faintest, most distant galaxies, for billions of years. What you are seeing is not the universe as it is now. You are seeing it as it was. It's a gentle idea, but one that slowly reshapes how you think about reality. Every star becomes a memory. Every galaxy, a message sent long ago only now arriving. In a way, the night sky is not just space. It is time stretched out above you. Now, if light takes time to travel, then there must be a limit to how far we can see. Not because our telescopes are too weak, or because our eyes are not sharp enough, but because the universe itself has not had enough time to send us the light. Imagine again that quiet field at night. This time, instead of a lantern, picture yourself surrounded by distant voices calling out in the darkness. Each voice takes time to reach you. Some are close, arriving quickly. Others are far away, arriving slowly, their echoes faint and stretched. And beyond a certain distance, there are voices that simply haven't reached you yet. Not because they don't exist, because their sound is still travelling. The universe works in a similar way, only instead of sound, it is light. And instead of seconds, the timescales are vast beyond everyday experience. Scientists estimate that the universe has been expanding for about 13.8 billion years. That number might feel abstract, but you can think of it as the amount of time light has had to travel since the beginning of everything we can observe. So, in the simplest sense, you might expect that we could see objects up to 13.8 billion light years away, since that's how long their light has had to reach us. But the reality is a little more subtle, because while light is travelling toward us, space itself is also stretching. It's as if the road between you and a distant destination is slowly growing longer, even as you move along it. So by the time the light finally arrives, the place it came from is much farther away than it was when the journey began. When scientists take this into account, they find that the most distant regions we can observe are not 13 billion light years away, but much farther, roughly 90 billion light years across from one side of the observable universe to the other. You don't need to hold on to that number. It's enough to feel what it represents. An immense sphere of visibility centered around us, not because we are special, but because we are here to observe it. Every point in the universe would see its own sphere like this, its own horizon of visibility, shaped by light and time. And this brings us to a quiet but powerful idea. The observable universe is not the whole universe. It is just the part we can see. Beyond that boundary, beyond that gentle horizon where light has not yet reached us, there may be more of the same, more galaxies, more stars, more cosmic history unfolding in silence, but we cannot see it. And more than that, we may never be able to, because the universe is not just expanding, it is accelerating. There is something in the fabric of space, often called dark energy, that causes distant galaxies to drift away from us faster and faster over time. And as they do, their light becomes more stretched, more faint, until eventually it can no longer reach us at all. It's a bit like watching boats drift away on an endless ocean. At first you can still see them clearly, then they grow smaller, dimmer, until they fade into the horizon. Not because they disappeared, but because the distance between you and them has grown too great. And so, even within the observable universe, there are places that are slowly slipping out of reach. Regions that were once visible, becoming forever hidden. This creates a kind of cosmic boundary, not just in space, but in possibility. A limit not only on what we can see, but on what we can ever interact with. There are galaxies whose light will never reach us. There are events unfolding right now in distant regions of the universe that will remain forever unknown, not because we lack the technology, but because the universe itself has placed them beyond our horizon. It's a quiet kind of separation, not dramatic, not sudden, just a gentle drifting apart, written into the expansion of space. And yet, even with this limitation, we can still think beyond it. We can imagine what lies outside our observable region. We can use the laws of physics, the patterns we see within our cosmic bubble, to make careful, thoughtful guesses about what might exist beyond, and what those laws suggest is something both simple and profound. If the universe appears roughly the same in every direction we look, then perhaps it continues in that way beyond our horizon as well, not ending at the edge, not fading into nothing, but simply continuing. More space, more galaxies, more of the same quiet structure, extending far beyond what we can ever confirm directly. And if that's true, then our observable universe is not the entire stage. It's just a small, illuminated portion of a much larger reality, a clearing in the fog. As this idea settles in, you might begin to feel a shift, a gentle widening of perspective, because the boundary we once imagined as the edge of everything becomes something else entirely, not an end, but a limit of perception, and beyond that limit, the fog remains, not empty, just waiting. In the quiet that follows, we'll begin to explore what happens when we take that idea seriously, when we consider the possibility that beyond our horizon, there may be not just more space, but many separate regions, each with their own view of the universe, each with their own story unfolding in parallel. There is a quiet assumption we often carry without noticing, that the universe we see tonight will always be there, that the distant galaxies, faint and shimmering at the edge of our telescopes, are part of a stable, unchanging backdrop, that no matter when we look up, the grand structure of the cosmos will remain, patiently waiting to be explored. But the universe does not quite work that way. It is not still. It is not fixed. It is, in a very real sense, drifting. And the further away something is, the faster it drifts. This idea first revealed itself slowly, through careful observation. When astronomers began measuring the light from distant galaxies, they noticed something subtle. The light was stretched, shifted gently toward the red end of the spectrum, as if the galaxies were moving away from us. At first, this was already surprising, but what came later was even more so. As measurements became more precise, scientists realized that this motion was not slowing down, as one might expect from gravity pulling everything together. Instead, it was speeding up. The expansion of the universe was accelerating. Something, still not fully understood, was pushing space itself outward, causing distant galaxies to recede from us faster and faster over time. This mysterious influence is often called dark energy, though the name is more of a placeholder than an explanation. It simply acknowledges that something is happening, even if we don't yet fully understand what it is. You might imagine space as a vast, flexible fabric. Not a rigid grid, but something more like a soft surface that can stretch and expand. Now picture small points scattered across that surface, galaxies, quietly embedded in the fabric. As the surface stretches, the points move apart, not because they are travelling through space, but because space itself is growing between them. And if that stretching accelerates, then the separation grows faster with time. At first the effect is gentle. Galaxies drift apart slowly, their light still able to reach us, carrying stories from across the cosmos. But as time passes, the stretching becomes more pronounced. The distances increase more rapidly, and the light they emit must travel across an ever-expanding gap. Eventually something subtle but profound begins to happen. The light struggles to keep up. Imagine again those boats drifting across a vast ocean. At first they move slowly, and you can watch them fade into the distance. But now imagine the ocean itself expanding, growing wider beneath them. Even if the boats continue sending signals, even if they shine bright lights back toward you, the growing distance becomes too great. Their signals stretch, weaken, and finally, never arrive. This is what will happen, slowly and inevitably across the universe. There are galaxies that we can still see today, whose light is reaching us after billions of years of travel. But because of the accelerating expansion, there are also galaxies whose light will never reach us no matter how long we wait. They exist, they shine, but they are forever beyond our horizon. And over time, this boundary will move inward. More and more galaxies will cross that invisible line, slipping out of reach. Not disappearing in a dramatic sense, but quietly fading from our observable universe, as if the fog were gently closing in again. If we could somehow fast forward far into the future, tens of billions, even hundreds of billions of years, we would witness a very different sky. The distant galaxies would be gone. The vast cosmic web, once stretching across unimaginable distances, would no longer be visible. The night sky would grow darker, emptier, more silent. Eventually, only a small cluster of galaxies would remain visible, those bound closely enough by gravity to resist the expansion. Everything else would have drifted too far away. It's a strange thought, that the universe, once so rich with distant light, could appear almost empty, not because it has lost its structure, but because that structure has become unreachable. In that far future, observers, if any exist, might look out into the cosmos and see only their local region. They might believe, quite reasonably, that their small cluster of stars and galaxies is all that exists. They would have no evidence of the vast universe that once was visible, no hint of the cosmic background glow that today marks the earliest light we can detect, no distant galaxies to suggest a larger structure. In a sense, they would be living in a smaller universe, not because reality has shrunk, but because their window into it has narrowed. And there's something quietly poetic about that, because it reminds us that what we see is not just a reflection of what exists, but of what we're able to observe at a particular moment in time. We happen to live in a brief era when the universe is still visible in its fullness, when distant galaxies can still be seen, when ancient light still reaches us, when the structure of the cosmos can still be mapped and understood. It is, in a way, a fortunate moment, a fleeting one. And as we sit here, quietly reflecting on these ideas, The process is already unfolding. Galaxies are already drifting beyond reach. The horizon is already shifting, not dramatically, not in a way we can notice from one night to the next, but steadily, patiently, like the slow return of fog across a quiet landscape. And yet, even as the observable universe shrinks in this way, something deeper remains unchanged: the existence of what lies beyond. Because even if we can no longer see those distant galaxies, even if their light never reaches us again, they're still there. The universe does not vanish, it simply becomes hidden. And that brings us gently to the next step in our journey. Because if there are regions of the universe that exist beyond our ability to observe or interact with, regions that are effectively separate from us, each with their own perspective, their own horizon, then perhaps we can begin to think of them in a new way, not just as distant places within a single universe, but as separate universes in their own right, each one a bubble of visibility, each one surrounded by its own horizon, each one unaware of the others. And from this simple shift in perspective, a new idea begins to emerge, the first step into what we call the multiverse. There is a quiet shift that happens when you begin to take the limits of observation seriously. Up until now, we've been exploring the idea that our view of the universe is bounded, that there is a horizon, not a physical wall, but a soft boundary shaped by light and time, a limit to what we can ever see or interact with. But once you accept that boundary, another question naturally begins to form. If we cannot see beyond a certain distance, what might be out there anyway? It's a simple question, and yet the answer it leads to is surprisingly vast. Because according to our best understanding of the cosmos, there's no clear reason for the universe to suddenly stop just beyond what we can observe. There is no known edge where space simply ends, no cosmic cliff where reality drops off into nothingness. Instead, everything we observe suggests something far more subtle. That space might continue, quietly, endlessly, in all directions. It's not an easy idea to hold on to at first. Infinity rarely is. But perhaps we can approach it gently, the same way we've approached everything else, through simple images and familiar experiences. Imagine standing on a perfectly calm ocean. No land in sight, no horizon you can reach, just water, stretching out in every direction, fading into the distance. Now imagine that no matter how far you travel, the ocean continues. There is no hidden shoreline, no distant boundary waiting to be discovered, just more ocean. The universe, at least in one possible picture, may be like that, an endless expanse of space, filled with galaxies, stars, and quiet pockets of cosmic structure, repeating, varying, unfolding in ways both familiar and strange. Now, if space truly does extend without end, something interesting begins to happen. Not immediately, not in a dramatic way, but logically. Because within any finite region, like our observable universe, there is only a limited number of ways that matter can be arranged. There are only so many ways atoms can come together to form stars, planets, and the patterns we see around us. It's a very large number, of course, vast beyond everyday comprehension, but still limited. And if the universe itself is infinite, if space stretches on forever, then those arrangements, however rare, must eventually repeat. Somewhere, far beyond our horizon, there may be another region of space where matter has arranged itself in a way that looks very similar to our own cosmic neighborhood. Not exactly the same, but close. And further still, there may be regions that are even more similar, until, at unimaginable distances, you might find a region that mirrors ours in every detail. A galaxy like the Milky Way, A star like the Sun, a planet like Earth, it's not something we can observe, not something we can verify directly, but it follows from a simple idea, that in an infinite space, even the rarest patterns have room to appear again, and again, and again. Now let's slow down here for a moment, because this is where the idea begins to feel a little unusual. You might find yourself wondering, if these regions exist, are they part of our universe, or are they something separate? And the answer depends on how we choose to think about it. Physically, they are part of the same overall structure, the same continuous fabric of space. There is no hard boundary dividing one region from another. But observationally, they're completely isolated. Because of the limits we discussed earlier, light travel, cosmic expansion, and the horizon of visibility, these distant regions can never interact with us. No signal can reach them. No message can be exchanged. No journey, no matter how long, could ever bridge the gap. They are, in every practical sense, separate. It's a bit like living in a vast, fog-covered landscape where small clearings exist, each illuminated from within. Within your own clearing, you can see the terrain, the shapes, the structures around you. But beyond a certain distance, the fog becomes too thick. You know the land continues. You can reason that it must, but you cannot see it, and you cannot reach it. Each clearing becomes its own little world, its own observable universe. And once we begin to think of these regions in that way, as separate bubbles of visibility within a larger, possibly infinite space, the idea of a multiverse starts to take shape. Not as something exotic or disconnected from physics, but as a natural consequence of it, a simple extension of what we already understand. This first step into the multiverse is sometimes described as the most grounded, the most conservative. It doesn't require new laws of physics or unfamiliar dimensions or dramatic shifts in how reality works. It simply takes what we already know and follows it a little further. If space may be infinite, and if observable regions are limited, then there may be countless such regions, each with their own view, their own history, their own arrangement of matter, each one unaware of the others. It's a quiet kind of multiplicity, not parallel worlds stacked on top of each other, not hidden dimensions folded out of sight, but a vast continuous expanse, gently partitioned by the limits of observation. And in that expanse, every region becomes its own story, its own universe, in a practical sense. As you sit with this idea, you might notice that it doesn't feel as dramatic as you might expect. There's no sudden leap into fantasy, just a gradual widening, a sense that the universe is not only larger than we imagined, but structured in a way that naturally gives rise to many separate perspectives, many separate worlds, each defined not by walls or barriers, but by horizons. And as this picture becomes clearer, something else begins to emerge. Because if these regions are infinite in number, and if the possible arrangements of matter are limited, then somewhere out there, among those distant and unreachable patches of space, there may be patterns that echo our own, not just galaxies and stars, but something closer, something more personal. And as we gently follow that thread, we'll begin to explore a question that feels both strange and familiar. What would it mean if somewhere, far beyond our horizon, there was another version of you? If space truly stretches on without end, then something quietly remarkable begins to follow. Not immediately, not in a way you would notice from moment to moment, but as a matter of simple logic. Because everything we experience, every star, every planet, every living being, is built from a finite set of ingredients, a limited collection of particles arranged in different patterns following consistent rules. You might imagine it like a vast set of building blocks. There are many ways to assemble them, almost unimaginably many, but still, not infinite in their variety within any given region. There are only so many ways those pieces can come together to form the structures we recognize. And if that is true, then in a universe that is truly infinite, where space extends endlessly in every direction, those patterns, however rare, must eventually appear again, not because they are likely, but because there is simply enough room. It's a bit like shuffling a deck of cards. Each shuffle creates a new arrangement, a new order of cards, and the number of possible arrangements is enormous. So large that even if you shuffled the deck every second for the entire age of the universe, you would almost certainly never repeat the same sequence. And yet, the number of possible arrangements is still finite, which means that if you could keep shuffling forever, truly forever, eventually one day, the same order would appear again, and then again, and again. In an infinite universe, something similar may be happening, but on a much grander scale. Instead of cards, we have atoms. Instead of hands shuffling, we have the natural evolution of matter under the laws of physics. And instead of seconds ticking by, we have endless stretches of space where every possible arrangement has the opportunity to unfold. Somewhere, far beyond the reach of our observable universe, there may be a region where matter has come together in a way that closely resembles our own cosmic neighborhood. A galaxy with a similar structure, stars arranged in familiar patterns, planets orbiting at distances that allow for calm, stable conditions, and on one of those planets, a world not unlike Earth, with oceans, continents, shifting clouds, and perhaps, on that world, beings who look up at their own night sky and wonder about the nature of reality, just as you are doing now. At first, this idea might feel abstract, distant, but as we follow it a little further, it begins to take on a more personal tone. Because if the number of possible arrangements is limited, and the universe provides infinite space for those arrangements to occur, then even the most specific patterns may repeat. Not just galaxies, not just planets, but configurations as detailed as human life. Somewhere out there in a region forever beyond our horizon, there could be a version of you, not metaphorically, not symbolically, but physically. A being composed of the same types of particles, arranged in the same pattern, following the same sequence of experiences. Someone who has lived a life nearly identical to yours, up to this very moment. Perhaps they are listening to a similar story. Perhaps they are lying awake, just slightly more tired, or slightly more alert, wondering about the same quiet questions. It's a strange thought, but also a gentle one, because it doesn't require anything magical. It doesn't depend on alternate dimensions or hidden forces. It arises simply from the combination of two ideas we have already explored: finite possibilities and infinite space. Now, it's important to pause here and let the idea settle without pushing it too far too quickly. Because while the logic suggests that repetition is possible, the distances involved are so vast that they remain completely unreachable. The separation between these similar regions would be far greater than anything we could ever traverse. Even if we imagine travelling at speeds close to that of light, the fastest anything can move, the journey would still take far longer than the current age of the universe. And because space itself continues to expand, that distance would only grow larger over time. So these other regions, these potential reflections of our own, are not places we could visit. They are not parallel worlds we might step into. They are simply there, existing quietly, independently, forever beyond our ability to interact. There is a certain calm in that, a recognition that even if such places exist, they do not interfere with our experience, They do not change the path we walk, the choices we make, or the meaning we find in our own lives. They are echoes, not influences, possibilities, not interruptions. And yet, the idea still has a way of shifting your perspective, because it gently loosens the sense that what we experience is unique in an absolute sense. Not less meaningful, just part of something larger. A pattern that may repeat not because it is trivial, but because the universe is vast enough to allow it. You might think of it like waves on an endless ocean. Each wave rises, takes shape, and fades away. From a distance, they may look similar, repeating patterns across the surface. But each one is still its own moment, its own form, its own expression of the underlying motion. Even if another wave forms in the same way, far away, it does not diminish the one you see before you. It simply reflects the nature of the ocean itself. And perhaps the universe is like that. An endless expanse, where patterns emerge, dissolve, and sometimes reappear, not by intention, but by possibility. As this thought gently settles, it prepares us for the next step. Because so far we've imagined a multiverse where everything follows the same basic rules, the same laws of physics, the same kinds of particles, the same underlying structure, just repeated across an infinite landscape. But what if that assumption is not required? What if, beyond our observable region, and beyond even this infinite repetition, the rules themselves can change? What if there are regions of reality where the fundamental forces behave differently, where the building blocks of matter follow unfamiliar patterns, where the very nature of existence takes on new forms? As we continue, we'll begin to explore that possibility, not just more space, but different kinds of worlds. There's a subtle shift in perspective that happens when distance becomes absolute. Up until now, we've been speaking about things that are far away, galaxies drifting across unimaginable distances, regions of space stretching far beyond anything we could ever reach. And yet, even in those vast scales, there is still a quiet assumption hidden beneath our thinking. The idea that, given enough time, we might one day get there. That distance is simply a matter of patience. But the universe, as it turns out, has a way of gently challenging that assumption. Because there are places in reality that are not just far away, but fundamentally unreachable. Not because of limitations in technology, not because we haven't figured out the right path, but because of the way space and time themselves behave. To understand this, let's return to a simple idea we've touched on before. Light takes time to travel. It is the fastest thing we know of, the ultimate cosmic messenger. Nothing moves faster. No signal, no object, no influence can outrun it. It sets the pace for how information spreads through the universe. Now imagine two regions of space drifting apart. At first, they are close enough that light can travel between them. A signal sent from one can eventually reach the other. There is a connection, however faint or delayed. But as the universe expands, the distance between those regions increases, and if that expansion accelerates, there comes a point where the space between them grows faster than light can cross it. Not because anything is breaking the rules, but because the space itself is stretching. You can picture it like two dots drawn on a balloon. As the balloon inflates, the dots move apart. If the balloon expands slowly, a small insect crawling across the surface might still travel from one dot to the other. But if the balloon expands faster and faster, there comes a moment when no matter how quickly the insect crawls, the distance grows too rapidly. The surface stretches beneath it, and the journey becomes impossible. In the universe, light plays the role of that insect, and space is the balloon. When the expansion becomes strong enough, there are regions where light can no longer bridge the gap. Signals sent from one side will never reach the other, no matter how long we wait. These regions become causally disconnected. It's a quiet phrase, but it carries a deep meaning. It means there is no cause and effect relationship possible between those regions. No influence can pass from one to the other. No shared history can be exchanged. They exist, but they exist separately, completely, and permanently. If you were to stand in one of these regions surrounded by galaxies and stars, you would have no way of knowing that the others exist. There would be no signal, no hint, no evidence reaching you from beyond your horizon. Your universe would feel complete, self-contained, whole. And the same would be true for observers in those distant regions. They would see their own galaxies, their own stars, their own quiet cosmic structure, and beyond a certain distance, nothing. Not because nothing exists, but because nothing can reach them. It's a bit like being in a room surrounded by thick, soundproof walls. You might hear the sounds within your own space, voices, movement, gentle echoes, but beyond the walls there could be entire worlds of activity, entirely hidden from you. Conversations you will never hear, events you will never witness. And no matter how long you wait, the silence remains. In the universe, these walls are not physical objects. They are created by the expansion of space itself. Invisible, intangible, but just as absolute. And so, as we take this idea seriously, something interesting begins to happen. Those distant regions we spoke about, the ones beyond our observable universe, start to feel less like distant parts of a single whole, and more like separate realities, not because they are fundamentally different in their composition, but because they are forever isolated. They cannot influence us. We cannot influence them. There is no bridge, no pathway, no hidden connection waiting to be discovered. Just distance turned into separation. And this is where a gentle shift in language begins to make sense. Instead of thinking of these regions as simply faraway parts of our universe, we can begin to think of them as separate universes in their own right, each one defined by its own horizon, each one containing its own observable region, each one unaware of the others. It's not a dramatic change, more like a quiet relabeling, a recognition that from the inside each region experiences itself as the whole, and from the outside, if such perspective were even possible, they are just small pieces of a much larger structure, a vast collection of isolated bubbles, each glowing softly with its own light, each surrounded by the fog of what cannot be seen. This is the first step into what is often called the multiverse, not a wild leap into speculation, not a sudden departure from known physics, but a natural consequence of ideas we've already explored. The expansion of space, the speed limit set by light, the finite age of the universe. Together they create a situation where reality is not one connected whole, but a patchwork of regions, each one complete in its own experience, yet separated from the others by the quiet rules of physics. And there is something almost calming about that, because it suggests that the universe is not just vast, but structured in a way that gently divides it into many separate perspectives, many separate worlds, not by design, but by inevitability, each one unfolding its own story, each one illuminated from within. As you sit with this idea, it may begin to feel less abstract, less distant, because in a sense you are already living inside one of these regions, a small, observable bubble within a much larger reality, a place where light has had time to arrive, where information can be exchanged, where the story of the universe, at least in this corner, can be told. And beyond that, the fog returns, not as emptiness, but as a boundary, a quiet reminder that there is always more, just out of reach. And yet, as vast as this picture may seem, it is still only the beginning. Because so far, everything we have imagined follows the same basic rules, the same laws of physics, the same kinds of matter, the same underlying structure. But what if that too is only part of the story? What if, beyond these isolated regions, beyond even this endless expanse, the rules themselves begin to change? There is a quiet question that sits beneath everything we've explored so far. Not about how big the universe is, or how far it extends, but something more subtle. Why does it work at all? Why does the universe allow stars to form, planets to settle, life to emerge, and minds like yours to sit here, gently wondering about it all? At first, this might not seem like a mystery. Things simply are the way they are. But when scientists began to look more closely at the underlying structure of the universe, they noticed something curious. The universe does not just work, it works. Precisely. Not in the sense of being perfect in a human way, but in the sense that many of its fundamental properties seem to sit within very narrow ranges. Small changes, tiny adjustments, could lead to a very different outcome. To get a feeling for this, imagine you're adjusting the flame on a stove. Turn it too low and the water never boils. Turn it too high and everything burns away too quickly. Somewhere in between, there is a gentle balance where things unfold just right. The universe appears to sit in a similar kind of balance. Take stars, for example. Stars are not just decorative lights in the sky. They are quiet engines of transformation, turning simple elements into more complex ones. Deep within their cores, they create the building blocks that eventually become planets, oceans, and living things. But for stars to exist at all, certain conditions must be just right. If gravity, the gentle pull that draws matter together, were slightly weaker, clouds of gas might never collapse to form stars. The universe would remain diffuse and empty, a quiet haze without structure. If gravity was slightly stronger, matter might collapse too quickly, forming dense objects that burn out almost instantly, leaving little time for anything stable to emerge. Somewhere in between, there is a narrow range where stars can form, shine steadily, and exist long enough to support the slow unfolding of complexity. And this is just one example. The forces that govern how particles interact, the masses of those particles, the way energy behaves across space, all seem to lie within ranges that allow for structure, stability, and change. If these values were even slightly different, the universe might look very different. Perhaps no stars, perhaps no complex atoms, perhaps no chemistry as we know it, and without those things, no life. It's a gentle realization but a profound one, that the universe, as we experience it, depends on a delicate balance of underlying conditions. Now, when scientists first noticed this, it raised an interesting question. Why? Why should the universe have these particular properties? Is it coincidence? Is it necessity? Or is there something else going on? One way to approach this question is through a perspective that feels almost quietly obvious once you hear it. It suggests that we're asking the question from within a very specific kind of universe, a universe where observers can exist. Because if the universe were very different, if it lacked stars or stable matter, or the ability to form complex structures, then there would be no one here to notice, no one to ask the question. It's a bit like walking into a room and noticing that the temperature feels comfortable, not too hot, not too cold. You might wonder why the room is set just right. But if the temperature were far outside that comfortable range, you probably wouldn't be there to experience it. This idea is often called the anthropic perspective, though the name is less important than the feeling behind it. We see the universe the way it is, because we are here to see it. It doesn't necessarily explain why the universe has these properties, but it reminds us that our perspective is shaped by the conditions that allow us to exist in the first place. And once you begin to think this way, another possibility starts to emerge, a quiet, expansive one. What if our universe is not the only possible version of reality? What if, instead of a single set of conditions, there are many different regions or different universes, each with their own values, their own rules, their own balance of forces? In some of them, the conditions might be too extreme, too chaotic or too simple, or too unstable for anything complex to form. In others, the balance might allow for stars but not planets, or planets but not life, or life but in forms entirely unfamiliar to us. And in a small number of these possibilities, perhaps the conditions align in just the right way to allow for something like our own universe, a place where stars shine steadily, where elements combine into rich chemistry, where planets orbit in calm, stable paths, and where, eventually, beings arise who can look out into the cosmos and wonder how it all came to be. In this picture, our universe is not uniquely designed. It is simply one of many where the conditions happen to allow for our presence, a quiet island of possibility within a much larger landscape. You might imagine it like a vast field filled with seeds. Each seed grows into a different kind of plant. Some struggle and fade quickly, others grow strong and stable. A few develop intricate structures, delicate patterns, complex forms. If you find yourself standing in one of the flourishing patches, it might feel natural to wonder why things are so well suited for growth. But perhaps it is simply because this is one of the places where growth was possible, and you are here to witness it. There is something both humbling and comforting in that idea. Humbling because it suggests that our universe may not be the only way reality can be, and comforting because it places our existence within a broader context, where possibility itself is vast and varied. As this thought settles in, it gently opens the door to the next layer of the story. Because if there are many possible kinds of universes, with different conditions, different balances, different ways of unfolding, then how do they come into being? Are they created all at once? Do they emerge from some deeper process? Do they form, grow, and separate, like bubbles rising through a vast cosmic ocean? As we continue, we'll begin to explore a picture of the universe that feels almost fluid, a reality not as a single static structure, but as something dynamic, expanding, evolving, and quietly giving rise to new worlds, again and again. There is a quiet moment in the life of every idea when it begins to change shape. Up until now, we've been imagining the universe as something large, perhaps even infinite, but still singular in its nature, a vast expanse of space, repeating patterns, and distant regions that we can never reach. But what if reality is not just large? What if it is generative? What if, instead of one continuous unfolding, the universe has a way of creating new regions, new worlds, again and again? To explore that possibility, we need to gently step back in time, far back, to the earliest moments of the universe, when everything we know was compressed into a state so dense, so energetic, that our usual ways of thinking begin to soften. In those first fleeting instants, something remarkable is believed to have happened. The universe expanded, not gradually, not at a steady pace, but in a sudden, rapid burst. It's often described as a kind of stretching, where space itself grew enormously in a very short span of time. Not matter moving through space, but space expanding within itself, like a surface being pulled outward in all directions. You might imagine a small, smooth balloon. At first it is tiny, almost unnoticeable, but then In a brief moment, it inflates rapidly, its surface stretching outward, carrying everything along with it. This early expansion is often called inflation, but rather than focusing on the name, it's more helpful to feel the idea: a sudden unfolding, a rapid opening of space, a quiet moment when the universe grew from something incredibly small into something vast enough to hold everything we see today. At first, this idea was proposed to explain certain features of the universe we observe, why space appears so smooth and uniform on large scales, why distant regions seem to share similar properties, even though they are far apart. Inflation provided a gentle answer. It suggested that these regions were once much closer together, before being stretched apart. But as scientists explored this idea more deeply, something unexpected began to emerge. The process of inflation might not have been a one-time event. It might not have switched off everywhere at once. Instead, it may have behaved unevenly. In some regions, inflation could have slowed down and ended, allowing matter to settle, stars to form, and a universe like ours to take shape. But in other regions, inflation might have continued, quietly, endlessly. If that is the case, then the universe is not just something that expanded once. It is something that is still expanding, in a deeper, more ongoing sense. And within this expanding backdrop, new regions can form. You might imagine a vast, gently simmering surface, like water just beginning to boil. At first, the surface is calm. Then small bubbles begin to appear. Each bubble forms, grows, and separates from the surrounding liquid, becoming its own distinct pocket. In a similar way, universes may form within this inflating space, each one like a bubble, a region where the rapid expansion slows down just enough for structure to emerge, where matter gathers, stars ignite, and a new cosmic story begins. Meanwhile, the space around it continues to expand, continuing the process, allowing more bubbles to form, not once, but over and over again. In this picture, our universe is not the only one. It is one bubble among many, each bubble separated from the others by the ongoing expansion of space, each one evolving independently with its own internal history. And because these bubbles are carried apart by the expansion itself, they remain isolated, forever out of reach. There is something quietly elegant about this idea. It doesn't require a deliberate creation of universes or a special mechanism designed to produce them. It arises naturally from the behavior of space itself, once we allow for the possibility that inflation continues, a kind of cosmic self-generation. Now, within each bubble, the conditions can settle in different ways. As space expands and cools, the underlying properties of that region, how particles behave, how forces interact, may take on specific values. It's as if each bubble chooses its own set of characteristics, not by intention, but by the way it forms. Some bubbles may end up with conditions similar to our own. Others may be very different. And most may not lead to anything complex at all, but all of them exist within the same larger process, a vast, ongoing expansion where universes form, drift apart, and continue their quiet evolution. You might picture it as a kind of cosmic foam, an endless sea where bubbles are constantly appearing, expanding, and separating, each one a self-contained world. And within one of those bubbles, you find yourself, not at the center of everything, not in a uniquely special location, but simply in one region where the conditions allowed for stars, planets, and the gentle emergence of life. There is something calming in that image, a sense that the universe is not a single, fragile structure, but part of a much broader, more resilient process. A process that does not rely on a single outcome, but allows for many. As this idea settles in, you might begin to feel the scale of it, not just in distance, but in possibility. Because if universes can form again and again, if each one can carry its own set of conditions, then the variety of possible realities becomes vast, far beyond what we can observe, far beyond what we can fully imagine. And within that vastness, something quietly sobering begins to emerge. Because if many universes exist, with many different conditions, then not all of them will be like ours. In fact, most of them may be very different, empty, silent, without the structures we take for granted. And as we continue, we'll gently explore that idea, not as something unsettling, but as a way of understanding just how rare and delicate our own universe might be. As the image of a bubbling cosmos begins to settle in your mind, something subtle starts to shift. Up until now, the idea of many universes may have felt expansive, even comforting. A vast sea of possibilities, where reality unfolds in countless ways, each bubble carrying its own story. But when you look a little closer, another thought begins to emerge. Not all possibilities are equal. In fact, most of them may be quiet. Imagine again that vast, simmering surface we spoke of. Bubbles forming, rising, separating, each one becoming its own self-contained world. Now imagine that within most of those bubbles, the conditions never quite settle into anything complex. No stable stars, no long-lived structures, no intricate chemistry slowly building toward life. Just simplicity, or chaos, or silence. It's not something we often think about, because our experience is shaped by the universe we inhabit. A place rich with structure, layered with complexity, filled with the slow, steady processes that allow galaxies, stars, and planets to form. But if the underlying conditions of each universe can vary, even slightly, then many of those variations may not lead to the same outcome. Let's return gently to the idea of balance. Earlier, we spoke about how certain properties of our universe seem to sit within a narrow range. Not too strong, not too weak, not too chaotic, not too rigid. Just enough to allow structure to emerge and persist. Now imagine adjusting those conditions, not dramatically, just a little. Perhaps the force that pulls matter together is slightly weaker. In that case, gas clouds might never collapse into stars. The universe would remain diffuse, like a soft mist, never forming the bright points of light we see in the night sky. Or perhaps that same force is slightly stronger. Matter collapses too quickly, forming dense objects that burn intensely but briefly, leaving no time for stable systems to develop. In another variation, the interactions between particles might be just a bit different. Atoms might not hold together in the same way. The rich chemistry that allows for molecules, liquids, and complex structures might never arise. Each of these possibilities is not impossible, they are simply different. And when you consider a vast collection of universes, each forming under slightly different conditions, it becomes likely that many of them fall into these quieter categories. Worlds without stars, worlds without light, worlds where matter never organizes itself into anything lasting. You might picture it like a garden, where seeds are scattered across a wide field. Some fall on fertile soil, where they can take root, grow, and flourish. Others land in places that are too dry, too rocky, too unstable. They remain dormant or fade before they can take shape. From the perspective of the seeds that do grow, the garden might seem full of life and possibility, but from a wider view, most of the field remains still, and perhaps the multiverse is like that, a vast landscape of potential, where only a small fraction of universes develop the conditions needed for complexity, a quiet rarity. Now it's important to approach this idea gently, because it can easily be misunderstood as suggesting that our universe is special in some absolute sense, chosen or designed with intention. But the perspective we're exploring here is softer than that. It suggests that given a wide enough range of possibilities, it is natural that some universes will develop conditions like ours, not because they were selected, but because, among many variations, some will inevitably fall within the narrow window where structure and life can emerge, and we find ourselves in one of those. There is a quiet humility in that thought, a sense that our universe is not the only one that could exist, but one of the few where certain patterns have had the time and stability to unfold. Stars that burn steadily for billions of years, planets that orbit in calm, predictable paths, elements combining into molecules, molecules into systems, systems into living forms, all of it resting on a delicate balance that could easily have been otherwise, and yet, here it is. As you reflect on this, you might notice a shift in how the universe feels, not just vast, but precious, not in a dramatic or emotional sense, but in a quiet, almost understated way, like finding a small, thriving island in the middle of a vast, silent ocean. The island does not need to be unique to be meaningful, it simply needs to be. And perhaps that is enough. As this idea settles, it prepares us for the next step in our journey. Because so far we've imagined universes forming in different ways, with different conditions, some quiet, some rich with structure. But there is another layer to consider. Another set of possibilities that go beyond how universes begin, and into how they might be connected or even born from one another. What if universes are not just separate bubbles in a cosmic foam? What if they can emerge from cycles, or from the collapse of stars, or from interactions between deeper layers of reality? What if the story of the multiverse is not just about variation, but about creation? As we continue, we'll gently explore these ideas, not as fixed answers, but as possibilities that expand the way we think about how worlds can come into being. As the idea of many universes begins to settle, another quiet question emerges. If universes can exist in many forms, then how do they come into being? So far we've imagined a kind of cosmic landscape where universes form like bubbles, emerging naturally from an expanding background. It's a calm and elegant picture, one where creation is not a single event, but an ongoing process. But this is not the only way to imagine it. In fact, as scientists have reflected on the nature of the universe, they have considered many different possibilities, not as competing answers, but as gentle explorations, different ways of asking how something as vast and structured as a universe might arise. One of these ideas is surprisingly simple. It suggests that the universe may not have a true beginning or end, but instead moves through cycles, a kind of quiet rhythm, expansion, followed by contraction, followed by expansion again. You might picture it like breathing, a slow inhale where space stretches outward, growing larger and cooler, and then perhaps a gentle exhale where everything begins to draw back together, compressing once more. In this view, what we call the beginning of the universe might not be the first moment of existence, but simply the start of the current cycle, a new phase in an ongoing process. It's a comforting image in a way, a universe that renews itself, not once, but over and over again, each cycle unfolding differently, shaped by what came before, but not entirely determined by it. However, there is a subtle challenge hidden within this idea. As systems evolve, they tend to become more disordered over time, not in a chaotic or dramatic sense, but in a gentle drifting toward randomness. You can see it in everyday life. A neatly arranged room slowly becomes cluttered. A cup of hot tea gradually cools to match the air around it. things tend to spread out, to settle, to lose their initial structure unless energy is added to maintain it. If the universe follows a similar pattern, then each cycle would carry a little more of this disorder forward. Over many cycles, that accumulated drift might make it difficult for the universe to reset cleanly to return to a state that allows for the kind of structure we observe today. It doesn't rule out the idea of cycles entirely, but it adds a layer of quiet complexity. Another possibility takes a different direction. Instead of the universe repeating itself over time, it suggests that new universes might form within existing ones, through the most extreme objects we know, black holes. Black holes are often imagined as endings, places where matter collapses inward, where gravity becomes so strong that nothing, not even light, can escape. But some have wondered whether they might also be beginnings. If the interior of a black hole is not simply a point of collapse, but a region where space and time take on new forms, then perhaps it could give rise to a new expanding region, a new universe, hidden from the outside, sealed off by the boundary of the black hole, but evolving independently within. In this picture, each universe could give birth to others. Stars form, some collapse into black holes, and within those black holes, new universes emerge. Over time, this process could repeat. A kind of cosmic branching, not through quantum possibilities as we'll explore later, but through physical creation. And just as living systems evolve through variation and selection, some have imagined that universes might do something similar. Those with conditions that favour the formation of many black holes might give rise to more offspring universes. Over time, the multiverse could become populated by universes whose properties naturally lead to further creation. It's a speculative idea, but a gentle one. A way of thinking about the cosmos not as static but as generative, even creative in a quiet, natural sense. There are other possibilities as well. Some suggest that our universe may exist as part of a higher dimensional structure, like a surface embedded within a larger space. In such models, what we experience as our universe could be just one layer among many, and occasionally these layers might interact, touching, colliding, or passing close enough to influence one another. In those moments, new regions of space could form, new beginnings emerging from the interaction. It's a bit like ripples forming where two waves meet on the surface of water. A brief moment of contact, followed by the emergence of something new. Each of these ideas, cycles, black hole origins, higher dimensional interactions, offers a different way of imagining how universes might arise. None of them are confirmed, none of them are final answers, but they share something important. They expand the range of what we consider possible. They gently loosen the idea that our universe must have formed in one specific way, and open the door to a broader landscape of creation. A landscape where universes can emerge, evolve, and perhaps even give rise to others. And as these possibilities drift through your thoughts, you might notice something interesting. The idea of the multiverse is no longer just about space. It is not just about distance or separation. It is about process, about the many ways reality might unfold. Not once, but again and again. And yet, even with all these variations, there is still a common thread. Each universe, however it begins, follows its own internal rules, its own structure, its own unfolding story. But what if we go one step further? What if the differences are not just in how universes begin, but in the very rules they follow? What if, at a deeper level, reality itself can take on entirely different forms? As we continue, we'll begin to explore a layer of the multiverse that feels less like separate worlds, and more like overlapping possibilities. Not different universes far away, but different outcomes, unfolding side by side. As the idea of universes forming in different ways begins to settle, there is one more layer we can gently explore. A layer that doesn't just change how universes are born, but changes what a universe is. Up until now, we've been imagining the universe as a vast three-dimensional space, with time quietly flowing alongside it. Length, width, height, and the gentle passage of moments. It feels natural, because it matches our everyday experience. But what if this familiar structure is only part of the story? What if reality has more dimensions than the ones we can directly perceive? It's not an easy idea to picture at first, but we can approach it slowly. Imagine a simple surface, like a sheet of paper. To a tiny creature living on that sheet, one that can only move forward, backward, left or right, the world would appear two-dimensional. It would have no sense of up or down in the way we do. From its perspective, the sheet would be the entire universe, flat, continuous, complete. But from our perspective, we can see something more. We can lift the sheet, bend it, move it through space. We can interact with it from a direction that the creature cannot perceive. To us, the sheet exists within a larger space. Now imagine something similar happening with our universe. What if the three-dimensional space we experience is like that sheet, a kind of surface, floating within a higher dimensional environment? Not something we can see or move through directly, but something that quietly surrounds and contains our familiar reality. In some theoretical models, the basic building blocks of the universe are not point-like particles, but tiny vibrating strands, so small that they are far beyond anything we could ever observe directly. These strands can vibrate in different ways, and those vibrations correspond to the different particles and forces we observe. You don't need to hold on to the details. It's enough to imagine that at the deepest level, reality may be more like a subtle pattern of vibrations, rather than solid objects. Now, for these vibrations to behave consistently, some models suggest that space itself must have more dimensions than we experience. Not large open dimensions like the ones we move through, but additional directions that are curled up, folded into extremely small scales. You might picture them like tiny loops at every point in space, invisible to us, not because they are far away, but because they are incredibly compact. Like the thickness of a thread woven into a fabric, you can feel the fabric as a whole, but the individual threads are too small to notice directly. Within this expanded view of space, something interesting becomes possible. Our universe, the three-dimensional space we inhabit, could be one layer within a higher dimensional structure, a kind of surface, sometimes described as a sheet, gently floating within a larger space. These sheets are often imagined as flexible, dynamic, able to move, stretch, and perhaps even interact with other similar sheets. You might imagine a series of thin membranes drifting quietly within a vast unseen environment, each one a universe, each one carrying its own set of particles, forces and internal structure. And while these sheets may be very close to one another in that higher dimensional sense, they remain separated in a way that prevents direct interaction. Like pages in a book stacked together, yet each one containing its own story. From within a single page, the others are not directly visible. They are there, but out of reach. Now, occasionally some models suggest that these sheets might come close enough to interact. Not in a dramatic collision, but in a gentle brushing, a subtle contact. And in those moments, energy could be transferred, structures could form, perhaps even giving rise to new regions of space, a new beginning. It's a delicate idea, and one that remains deeply theoretical. but it offers a different way of imagining the multiverse, not just as distant regions separated by space, and not just as bubbles forming within an expanding background, but as a layered structure, a quiet stack of universes, each one a surface within a deeper reality. And within this picture, something begins to shift. The multiverse is no longer just about distance, it's about depth, about the possibility that reality extends not only outward, but inward into dimensions we do not directly perceive. There is something almost poetic about that, because it suggests that even in the space we occupy right now, there may be more structure than we can see, not hidden far away, but woven into the very fabric of existence. And yet, for all its elegance, this idea carries a gentle uncertainty. These extra dimensions, these cosmic sheets, these deeper layers, they are not things we have observed directly. They arise from attempts to unify different parts of physics, to bring together our understanding of forces and particles into a single coherent picture. They are possibilities, carefully considered, thoughtfully explored, but still open. And that openness is part of what makes this journey feel so calm. We are not being asked to accept a single answer, only to sit with the possibilities, to let them drift gently through the mind like shapes in the fog. Because as we move forward, we're about to encounter a different kind of idea altogether, one that doesn't place other universes far away or hidden in higher dimensions, but suggests that different realities may exist right alongside this one, not separated by distance, not separated by layers, but separated by possibility itself. There is a point in any journey through science where the ground beneath your understanding begins to feel less solid. Up until now, the universe has expanded outward in ways that, while vast, still follow a kind of familiar logic. Space grows, regions separate, universes form. The rules may change, but the structure still feels continuous. But as we move deeper into the smallest scales of reality, something subtle begins to shift. Not dramatically, just enough to make things feel a little uncertain. It begins with light. Light is something we experience every day. It illuminates the world, reveals shapes, fills the sky with colour. It feels simple, almost obvious. And yet, when scientists began to study it closely, they discovered something that didn't quite fit with ordinary intuition. Light behaves in more than one way. Sometimes it acts like a stream of tiny particles, small packets of energy moving through space. Other times it behaves like a wave, spreading out, overlapping, forming patterns of peaks and valleys. At first, this might not seem too strange. After all, many things can behave differently under different conditions. But then came a simple experiment, one that revealed something far more unusual. Imagine a flat surface with two narrow openings cut into it. Behind that surface is a screen. Now imagine shining a beam of light toward those openings. If light were purely made of particles, tiny independent points, you might expect those particles to pass through one opening or the other, forming two bright regions on the screen behind. And in some cases that is exactly what happens. But under certain conditions, something else appears. Instead of two simple regions, the screen fills with a series of light and dark bands, a delicate pattern of stripes, as if waves have overlapped and interfered with one another. It looks less like particles, and more like ripples on water, spreading out and interacting. This suggests that light, in some sense, passes through both openings at once, spreading out, overlapping with itself and creating an interference pattern. Already, this is a little unusual, but what makes it truly remarkable is what happens next. If you try to observe which opening the light passes through, if you place a detector, a gentle measurement device, to see the path, something changes. the pattern disappears. The delicate bands of light and dark fade away, replaced by the simpler pattern you would expect from particles passing through one opening or the other. It is as if the act of observing changes the outcome. Now, it's important to approach this idea carefully, without rushing to dramatic conclusions. Nothing mystical is happening, but something subtle is. At very small scales, reality does not behave in the solid, predictable way we experience in everyday life. Instead, it seems to exist in a kind of openness, a range of possibilities. Before observation, the system behaves like a spread-out wave of potential outcomes. After observation, it settles into a more definite state. You might imagine it like a soft cloud. Before you look closely, the cloud is diffuse, spread out, not fixed to a single shape. But as you focus on it, it seems to take on a more defined form, not because your attention changes it directly, but because the process of interaction brings out a particular outcome from among many possibilities. This idea can feel a little abstract, so it helps to return to something simple. Imagine tossing a coin. Before it lands, there is a sense of openness. It could be heads, it could be tails. Both outcomes are possible. Once it lands, the possibility collapses into a single result. In everyday life, this process feels straightforward, but at the quantum level, things are less settled. The coin doesn't simply have a hidden result waiting to be revealed. Instead, it exists in a state where multiple outcomes are, in a sense, present at once, until something causes one of them to emerge clearly. This doesn't mean that reality is vague or undefined, but it does mean that our classical picture, where everything has a definite state at all times, may not fully apply at the smallest scales. And this is where the ground begins to soften. Because if even light, something so familiar, can behave in this dual, almost fluid way, then perhaps the deeper structure of reality is not as fixed as it seems. Perhaps, beneath the solid surface of our experience, there is a layer of possibility, a quiet openness, a place where outcomes are not yet decided, where multiple paths exist, gently overlapping, waiting for the moment when one becomes visible. And as you sit with that idea, you may begin to feel a subtle shift. The universe is no longer just vast in space or varied in its laws. It is also flexible in its outcomes. And that flexibility leads us gently toward the next question. If, at the smaller scales, reality contains multiple possibilities, then what determines which one becomes real? Does the universe simply choose one path? Or is there another way to understand what is happening? As we continue, we'll begin to explore a picture where those possibilities are not lost, but quietly unfold, side by side. As we sit with the strange behavior of light, something begins to quietly unfold. What we observed was not just a curiosity about how light behaves. It was a hint, soft, almost whispered, that at the deepest level reality might not be as fixed as it seems. Instead of solid, well-defined objects moving along clear paths, we begin to glimpse something more fluid, a kind of openness, a space where multiple possibilities can exist, not one after the other, but together. To explore this gently, scientists developed a way to describe these possibilities, not as solid objects, but as a kind of spread-out pattern, a description of all the ways something could be. This description is often called a wave function, but the name is less important than the feeling behind it. You might imagine it as a soft, invisible cloud. Not a cloud made of water, but a cloud of potential. Within this cloud, different outcomes exist as possibilities, some more likely, some less so, but all present in a quiet, overlapping way. If we return to the idea of the coin, it is no longer just a simple flip between heads and tails. Before it lands, It is as if both outcomes exist within this cloud of possibility, not as separate events, but as a single, unified state that contains both. Now, in our everyday experience, we never see this cloud directly. We only ever see the result. The coin lands, the outcome appears, and the other possibilities fade quietly into the background. But at the quantum level, this underlying cloud is not just a convenient idea. It appears to be part of how reality actually behaves. And this leads us to a question that has puzzled scientists for a long time. If reality begins as a range of possibilities, what determines the final outcome? Why does one result appear while the others do not? This is sometimes called the measurement problem, though again, the name is not as important as the feeling of the question. It is the quiet mystery of how potential becomes actual. At first, one might imagine that the act of observation itself causes this change. That by measuring or interacting with a system, we somehow force it to choose a single outcome. But this idea raises further questions. What counts as an observation? Does it require a human observer, or is any interaction enough? And if interaction is the key, then why does the outcome appear so definite, so singular? To approach this gently, it helps to step away from the technical details and return to imagery. Imagine a calm lake at night. The surface is smooth, undisturbed. Beneath it, there are many possible ripples that could form, patterns that could spread across the water if something were to touch it. Now imagine dropping a small stone. The moment it touches the surface, ripples begin to spread. One pattern emerges. The others, the ones that could have formed under slightly different conditions, do not appear. But in a sense, they were always possible. They were part of the underlying openness of the system. The wave function is a bit like that calm surface, a quiet space of possibility. And measurement, or interaction, is like the stone, bringing one pattern into focus. But here is where things become more subtle, because some interpretations of quantum physics suggest that those other possibilities do not simply vanish. They do not disappear entirely. Instead, they may continue to exist in a way that is not directly visible to us. It's a gentle idea, and one that requires a soft touch. Rather than imagining reality as choosing one path and discarding the others, we begin to consider the possibility that all paths may still be there, unfolding in their own way, not overlapping in a way we can perceive, not interacting in a way we can detect, but existing quietly, side by side. You might imagine walking through a forest where many paths branch out in different directions. At each step, you choose one path to follow. From your perspective, that path becomes your reality. The others fade from view, hidden by the trees, no longer part of your experience, but from a wider perspective, those paths still exist. They simply lead somewhere else. And so, the question deepens. When a quantum system evolves from possibility into outcome, is it truly collapsing into a single reality? Or is it branching, gently, continuously, into multiple realities, each carrying one version of what could happen? At this stage, we're not yet answering that question. We are simply allowing it to take shape, because it marks a turning point in how we think about the universe. Until now, we've explored multiple universes as separate regions of space, or as different outcomes of cosmic processes. But here, the possibility is different. It suggests that the splitting of reality might not happen across vast distances or through dramatic events, but within the very fabric of everyday processes, quietly, constantly, every time a possibility becomes an outcome. As you let this idea settle, you might notice that it doesn't feel loud or overwhelming. It feels subtle, like a shift in perspective rather than a dramatic change. The world around you remains the same, the room, the quiet, the steady rhythm of your breath, and yet beneath it, there may be a deeper layer where possibilities unfold in ways we do not directly perceive, and as we continue, we will gently step into that idea, not as a conclusion, but as an invitation to imagine a reality where every possibility finds a place, and where the universe does not choose a single path, but allows many to unfold side by side. As the idea of possibilities quietly unfolding begins to take shape, there is one more step we can gently take, a step that does not force reality to choose, but instead allows it to expand. Up until now, we've been exploring a question. When a system moves from many possibilities into one outcome, what happens to the rest? Do they disappear? Do they collapse into nothing? Or do they continue in some hidden way? One way of thinking about this is surprisingly simple. It suggests that nothing needs to disappear at all. That instead of collapsing into a single outcome, reality may simply branch. Not dramatically, not in a way that tears the universe apart, but quietly, smoothly, like a path dividing in a forest. Imagine walking along a gentle trail. At some point, the path splits into two directions. One curves to the left, the other to the right. From where you stand, both paths are possible. Both extend forward, each leading to its own destination. Now, in everyday life, you choose one. You turn left, perhaps, and the other path is left behind. But in this picture of reality, something different happens. Instead of one path being taken and the other abandoned, both paths continue, and with them, two versions of the journey, not interacting, not aware of one another, but each unfolding in its own quiet way. This is the essence of what is often called the many worlds interpretation, the idea that every possible outcome of a quantum event is realized, not in sequence, but in parallel. Each possibility becomes part of its own branch of reality. You don't need to imagine worlds popping into existence with flashes or sounds. It is much softer than that, more like a continuous unfolding, where the fabric of reality gently separates into distinct threads, each carrying a different version of events. If we return to the coin, we can feel this more clearly. In the familiar picture, you flip a coin and it lands either heads or tails. One outcome, one reality. But in this alternative view, both outcomes occur. The coin lands heads in one branch and tails in another. From within each branch, the outcome feels definite, clear, singular. You never experience both at once, because you are part of the branch where one outcome is unfolded. The other remains beyond your awareness, not because it vanished, but because it exists along a different path. At first, this might feel like a large leap, but there is a quiet logic to it, because earlier, we encountered the idea that before observation, a system exists as a range of possibilities, a soft cloud of potential outcomes. Now, instead of asking how that cloud collapses into one result, this interpretation suggests that the cloud never truly collapses. It simply evolves, expanding into multiple non-overlapping realities, each one carrying a different outcome forward. It is, in a sense, a way of preserving all possibilities without needing to choose between them. And when you begin to see it that way, something interesting happens. The multiverse is no longer something distant. It is not just faraway regions of space or bubbles forming in an expanding cosmos. It becomes something much closer, something that unfolds with every interaction, every event, every moment where multiple outcomes are possible. A quiet branching, happening continuously. Now, it's important to approach this idea gently. because while it is a natural extension of certain interpretations of quantum physics, it is not something we can directly observe. We do not see the other branches. We do not step between them. From our perspective, reality still appears singular and continuous, and that is enough for everyday life. But beneath that appearance, there may be a deeper structure, where all possibilities find expression. You might imagine it like a great tree. At its base there is a single trunk, but as it grows, it branches outward. Each branch splits again and again, creating a vast, intricate structure of paths. From within one branch, you see only your own path, but the tree as a whole contains many, and it continues to grow, not in sudden leaps, but in a steady, quiet unfolding, as each new possibility gives rise to new branches, and those branches continue forward. There is something both expansive and calming in that image, because it suggests that the universe does not need to discard possibilities. It does not need to reduce itself to a single line of events. Instead, it can hold many paths at once, each one consistent within itself, each one part of a larger structure. And as you sit with that thought, you might begin to feel a shift, a gentle widening of perspective. Because if every possible outcome unfolds, then reality is not just a single story. It is a collection of stories, all being told at once, not intersecting, not interfering, but coexisting, quietly. And yet, from within your own experience, nothing changes. You still follow one path, you still move through moments, one after another, with a sense of continuity and presence. The branching, if it exists, happens beneath that experience, beyond direct perception, like roots growing beneath the surface of the earth, unseen but shaping the structure above. And as this idea settles, it leads us gently toward one more reflection. Because if reality branches in this way, if multiple versions of events unfold side by side, then what does that mean for identity, for continuity, for the sense of you moving through time? As we continue, we'll explore a thought experiment that brings this question into focus, not as something to resolve, but as something to gently consider. As the idea of branching realities settles quietly into place, a more personal question begins to take shape, not about distant universes or abstract possibilities, but about you. If reality can unfold into multiple paths, if every possible outcome finds its own quiet expression, then what does that mean for the path you experience? To explore this gently, we can consider a simple thought experiment, not something meant to be taken literally, but something that helps us feel the shape of the idea. Imagine a situation where the outcome is uncertain. A coin is flipped. Heads, you continue. Tails, something ends. In everyday life, this is just a simple moment of chance. The coin lands, and one outcome becomes real. But in the picture we've been exploring, both outcomes occur. In one branch, the coin lands heads, and the story continues. In another, it lands tails, and the path ends there. Now, from an outside perspective, if such a perspective were possible, both branches exist. Two different continuations of reality, but from within a single branch, the experience is always singular. You only ever find yourself in one path, the one that continues. And this leads to a curious idea. If there are many branches, and in some of them your path ends, while in others it continues, then from your own perspective you would only ever experience the branches where continuation happens, not because the others don't exist, but because there is no experience within them to carry forward. This is sometimes called the idea of quantum immortality, but the name can be misleading, so it's best to approach it gently. It is not a claim about living forever. It is not a prediction. or something that can be tested in any practical sense. It is simply a way of thinking about how perspective works within a branching structure of reality. From the inside, experience follows continuity. It moves along the paths where events unfold, where awareness continues from one moment to the next. Branches where that continuity stops are not experienced. They exist, perhaps, as part of the larger structure, but they do not contain a viewpoint that continues to observe them. You might imagine it like a series of stories. At certain points, some stories come to an end, others continue. If you are reading one of those stories, you naturally follow the one that keeps going. The others are not part of your experience, even if they exist in the larger collection. In this way, your perspective is always aligned with continuity, with the path that unfolds. And while this idea can feel unusual, it also carries a quiet simplicity. Because in everyday life, we already experience time in this way, moment by moment, one event leading into the next. We do not experience the paths not taken. We do not feel the branches that diverge beyond our awareness. We simply move forward along a single thread. The thought experiment we're exploring doesn't change that. It simply suggests that this thread may be part of a larger tapestry, where many threads exist, each one following its own course, and your experience is tied to one of them, the one where awareness continues. Now, it's important to keep this grounded. This idea is not something that can be observed directly. It is not a practical description of how to live or act. It is a reflection, a way of thinking about how identity and continuity might behave in a universe where many outcomes unfold. And even within that reflection, there are many open questions. What does it mean to be the same across different branches? Are these versions truly identical at first and then slowly diverging? Or are they fundamentally separate from the beginning? There is no clear answer, and that's part of what gives this idea its quiet, contemplative quality. It invites thought without demanding resolution. As you sit with it, you might notice that it doesn't need to be taken literally to have meaning. It simply highlights something subtle about experience. That from the inside, life always feels like a continuous flow, a steady movement from one moment to the next, and whatever deeper structure may exist beneath that flow, branching, expanding, unfolding, it remains just beyond direct perception, like the roots of a tree, hidden beneath the surface. And perhaps that's where we can leave it. Not as a conclusion, but as a gentle pause, a moment to notice that the universe, whether singular or branching, whether simple or vast, is experienced one moment at a time, through a single path, your path. And that path, however it may be connected to others, is enough. It carries you forward, quietly, through the unfolding of events, and as it does, it brings you here, to this moment, to this thought, to this quiet exploration of what reality might be. As we move forward, we'll begin to shift once more, away from branching paths and parallel possibilities, and toward a deeper question, one that asks not just how many universes exist, but what reality itself is made of at its most fundamental level. As the idea of branching realities begins to fade into the background, a quieter, deeper question starts to take its place. Not about how many universes there are, not about where they exist, but about something more fundamental. What is reality made of? It's a question that has lingered for a long time. At first, the answer seemed simple. Reality is made of things, solid objects, particles, tiny building blocks that come together to form everything we see and touch. But as we've gently explored, that picture has already begun to soften. Particles behave like waves. Objects emerge from deeper patterns. And what we experience as solid often turns out to be something more subtle. Now imagine taking one more step. Instead of asking what things are made of, ask what their structure is, not their substance, but the pattern they follow. Because when scientists describe the universe, they often do so using mathematics, not because mathematics is convenient, but because it seems to capture something essential: the motion of planets, the behavior of light, the interactions between particles. All of these can be described with patterns that are precise, consistent, and deeply interconnected. You don't need to think of these patterns as equations or symbols. It's enough to imagine them as relationships. Simple, elegant rules that describe how things change, how they move, how they relate to one another. And what's remarkable is that these patterns don't just approximate reality. They seem to match it exactly. Again and again, across different scales, different phenomena, different areas of study, this has led some thinkers to consider a quiet possibility. What if mathematics is not just a language we use to describe the universe? What if it is the underlying structure of the universe itself, not something applied from the outside, but something that is reality at its deepest level? It's not an easy idea to grasp, so let's approach it gently. Imagine a piece of music. When you listen to it, you hear melodies, rhythms, harmonies. It feels expressive, emotional, alive. But beneath that experience there is structure, patterns of timing, relationships between notes, sequences that follow certain rules. You could write those patterns down, you could describe them. But the music itself is not separate from those patterns. It is those patterns unfolding in time. Now imagine something similar for the universe. What we experience, the stars, the planets, the quiet flow of time, may be like the music, and beneath it there may be a deeper structure. Not made of matter in the usual sense, but of relationships, patterns, a kind of mathematical harmony. In this view, reality is not built from stuff in the traditional sense. It is built from structure, and if that is true, then something remarkable follows. Because mathematics is not limited to a single structure. There are many possible patterns, many possible systems, many ways that relationships can be arranged. Some simple, some incredibly complex, some stable, others fleeting. If all of these structures exist in a mathematical sense, then perhaps in some deeper way they also exist physically. Not all in the same place, not all interacting. But each one has its own complete reality, its own universe. This is sometimes called the idea of a mathematical multiverse, a picture where every consistent structure, every possible pattern, exists as its own form of reality. You don't need to imagine them as floating in space or arranged in layers. They are not necessarily located anywhere in the way we understand location. They simply are. Each one self-contained, each one defined by its own internal rules. And within some of these structures there may be complexity, stability, processes that give rise to something like time, like space, like matter. And perhaps, in a small subset of them, there are observers, beings capable of experiencing, reflecting, wondering, and those observers would perceive their universe as real, just as we perceive ours, not because it is uniquely special, but because it is internally consistent. There is something both expansive and quiet about this idea, because it takes the concept of the multiverse to its most abstract form. Not just many regions of space, not just many bubbles of expanding reality, not just many branching outcomes, but many possible structures, all existing, all valid in their own way. Now it's important to approach this gently. This is not a confirmed description of reality. It is a philosophical extension of ideas in physics and mathematics, a way of exploring what might be true if the patterns we observe are not just descriptions but the foundation itself. And like many ideas at this level, it remains open, unsettled, part of the fog that still surrounds our understanding. But even as a possibility, it invites a shift in perspective, because it suggests that reality may not be a single fixed thing, but a vast landscape of structures, each one expressing a different version of existence. And within that landscape, our universe is one pattern among many, a particular arrangement of relationships, a specific kind of harmony, one way for reality to be. As you sit with that thought, you might notice that it doesn't feel overwhelming. It feels spacious, like stepping back and seeing a larger picture without needing to grasp every detail. Because at the end of the day, whatever the deeper structure may be, you are still here, experiencing this particular pattern, this particular unfolding of reality. And that experience, simple and immediate, remains unchanged, even as the ideas around it expand. And as we move toward the final part of our journey, we'll gently gather these ideas together, not to resolve them completely, but to see what they reveal about the nature of the question itself. As all of these ideas begin to settle, something quiet remains. Not a final answer, not a single clear picture that ties everything together, but a feeling, a sense that the question we started with, how many universes are there, may not have a simple answer at all. Because along the way, something subtle has happened. The idea of the multiverse has expanded. At first, it was about space, the possibility that beyond what we can see, there are more regions, more galaxies, more of the same structure extending endlessly. Then it became about variation, different universes forming under different conditions, each one with its own balance, its own quiet unfolding. Then it became about branching, possibilities splitting, outcomes diverging, multiple paths existing side by side. And finally it became something even more abstract, a landscape of patterns, a suggestion that reality itself might be one of many possible structures, each one complete in its own way. And through all of these layers, one thing becomes clear. The multiverse is not a single idea. It is a collection of ideas, different ways of extending what we already know, just a little further. Some of these ideas are grounded in observations, careful measurements of the universe's expansion, the patterns in the oldest light we can detect, the behavior of particles at the smallest scales. Others are more speculative, attempts to follow the logic of those observations into places we cannot yet test. And this brings us to an important, gentle truth. We do not yet know which of these ideas, if any, fully reflects reality. The multiverse in all its forms remains an open question, not because it is vague or unclear, but because it reaches beyond what we can currently observe. Science, at its heart, is a process of careful exploration. It builds on what can be measured, what can be tested, what can be confirmed through repeated observation. And while some aspects of the multiverse connect to these foundations, others stretch into regions where direct evidence is difficult or perhaps impossible to obtain. That does not make them meaningless, but it does place them in a different space, a space between science and philosophy, between what we know and what we can imagine. There is something quietly beautiful about that space, because it allows us to explore possibilities without needing to fix them into certainty, to consider different ways reality might be, without demanding that one must be true above all others. And even within this uncertainty, there are small hints, gentle clues that may, over time, guide us further. Some scientists look for subtle patterns in the faint glow of ancient light, the cosmic background that carries information from the earliest moments of the universe. Others explore the behaviour of particles and fields, searching for signs that might point towards deeper structures. There are even ideas about possible interactions between distant regions, faint imprints that might suggest contact between different bubbles of reality. So far, nothing conclusive has emerged, but the search continues, quietly, patiently, like all scientific exploration, and perhaps that is part of what makes this journey feel so calm. We are not rushing toward an answer, we are simply looking a little further, letting the light extend into the fog, because the fog, as we began to notice, never truly disappears. It shifts, it moves, it reveals new shapes as we explore, but always leaves something beyond, and that is not a limitation. It is part of the experience. The universe is not just something to be solved. It is something to be encountered, to be wondered about, to be felt in a quiet and open way. As you reflect on everything we've explored, the endless space, the distant regions, the bubbling universes, the branching paths, the deep mathematical structures, you might notice that each idea adds something. Not certainty, but perspective. Each one gently expands the way you think about reality. And perhaps that is the most meaningful outcome. Not knowing exactly how many universes exist, but understanding that reality may be far richer, far more layered than it first appears. And within that richness, there is room for both knowledge and mystery, both structure and possibility, both clarity and fog. And so, as we come to the end of this quiet exploration, there is no need to arrive at a final conclusion. It is enough to sit with the question, to let it remain open. Because sometimes the most meaningful questions are not the ones we answer, but the ones that continue to gently expand our view. And so, we return to where we began, a small light in a vast quiet fog, a light that has grown a little brighter, revealing a little more of what surrounds it, but still leaving space for what lies beyond. And that space is where curiosity lives, where wonder remains, where the journey continues, softly, endlessly, just out of reach. And so, we've reached the end of tonight's exploration. Whether your eyes are still open, or you're already floating somewhere between waking and dreaming, thank you for being part of this little journey. If you'd like to join me again for more gentle wanderings, you're always welcome to subscribe or share this with someone who could use a peaceful pause. Time has a way of slipping through our fingers, but here, in this quiet moment, it's just you and the soft hush of rest. Sleep peacefully wherever and whenever you may be.